Right there, I'd say we're diving into the fascinating and sometimes puzzling world of brain health, especially when it comes to those head bumps and their long-term effects. Ever heard of chronic traumatic encephalopathy, or CTE? It's a mouthful, but basically it's a brain condition linked to repeated head trauma, like in athletes or accident survivors. Sometimes it's called traumatic encephalopathy syndrome. This condition can lead to a whole host of issues, including cognitive troubles like memory loss or difficulty concentrating, mood swings, behavioral changes, and even motor impairments that affect movement. Over time, these symptoms can escalate into dementia, which is a fancy way of saying severe memory and thinking problems, or just a general cognitive decline. People might also experience executive dysfunction, struggling with planning or decision making, and mood disorders like depression and anxiety. Now, what's actually going on inside the brain? Well, the pathogenesis involves a lot of complex processes. When the brain experiences trauma, it triggers neuroinflammation, kind of like an immune system response gone a bit overboard and causes brain pathology, meaning changes in brain tissue. This includes the accumulation of neurotoxic materials like tau proteins, which can form insoluble fibrils and tangles inside neurons, particularly in the cortical pyramidal neurons of the superficial layers. Tau proteins usually help stabilize the internal structure of neurons, but in these conditions they get hyperphosphorylated and form what are called phosphorylated tau or p-tau. These abnormal tau proteins can stick together, forming neurofibrillary tangles that disrupt normal brain function. Enzymes like kinases, including C-Jun and terminal kinase, are involved in this process by phosphorylating tau, which then leads to its aggregation. But tau isn't the only villain here. Amyloid pathology also plays a role, with amyloid precursor proteins being cleaved by enzymes such as secretases like beta-secretase, presenilin, nicostrin, PEN2, and APH1, producing amyloid beta peptides. These peptides can aggregate into soluble forms and eventually form plaques outside neurons called diffuse plaques that contribute to brain damage. All this cellular chaos impacts neuronal functions like axonal transport, sprouting, and synaptogenesis, formation of new connections. When neurons are damaged, it affects the axons, the long projections that send signals that can cause axonal bulbs and damage to the entire network of nerve cells. Microglia, the brain's resident immune cells, get activated in response to these proteins, aggregates, and debris. They act like the brain's cleanup crew. Phagocytosis, think of it as eating up cellular debris, protein clumps, and damaged synapses. Interestingly, the brain has a special drainage system called the lymphatic and meningeal-lymphatic system, which help clear out waste and protein buildup. In the end, maintaining brain health is a delicate balance, like managing a busy city where garbage collection, traffic flow, and infrastructure all need to work together. Understanding each process helps us appreciate why protecting our heads and supporting brain health is so vital. Thanks for tuning into this brain adventure. Stay curious and take good care of your brain.